I have some other topics I'd like to move into, and one of the interesting, I think, unique knowledges that you have is that you've been working with HPC and you've been working with AI, you've been working with big data, and I know we even sent people from Peltorian to your course in big data and things like that, and you know, you're an authoritative, so to speak, in these kind of fields. Let me make a statement, and you can disagree and have a discussion about this. But I would say, you know, I think a few people understand the difference or the problem with moving from having an algorithm, whatever it is, running on a single CPU with a shared memory, into moving into, let's say, a big data setting. And there is a lot of work you have to do to change that algorithm, make it work in a parallelized setting. I hope you agree so far, right?
Yeah.
And I would argue that although that HPC and AI are different in terms of how the parallelization works and how the shared memory works, it's still the same problem if you want to move something to an HPC or traditional HPC setting and like a GPU-based AI setting. Would you agree with that as well?
Yes.
Yeah. Mm-hmm. Yeah. And speaking, you know, as the big data expert you are, and you know, giving courses from RISE and whatnot in this, what would you say the top challenges are in trying to have an algorithm, whatever kind of search algorithm and whatnot, and making that work in a parallelized fashion on like Hadoop, Spark, or something like that? What are the problems with that, really?
Okay, the first problem is why do you even do this in the first place? Mm-hmm. So the first rule of distributed systems is avoid distributed systems. So
especially Hadoop, right?
Well, or any. In many cases, you can. Let me back off a bit here. Let me tell you an anecdote. I was contacted by a Finnish startup, and they needed some assistance. They had some machine learning jobs or whatever. They couldn't get to work, and they used to work, but they don't anymore. So okay, what happened? Well, and there was some rounds back and forth. I couldn't figure out what they were doing wrong, and then they gave me a link to a blog post. Here, these guys have the same problem. The problem is S3. They had their data in S3. The S3 and Spark. Okay. And it turns out, when I read the blog post, I realized that there was this company, and every time they retrained, and every time they processed with all of the data cleaning, feature extraction, preparation, and then retraining, they were doing that on all history, but way back to like 2013 or when they started. And this worked great for a while, and then became slower and slower and slower and slower, right? And we actually had a case of that, I think, at Spotify as well, which was discovered only when we moved to the cloud, because there were these people that were reprocessing all of the data since way back in time. And turned out they had taken like 10% of the Hadoop cluster, and nobody ever noticed. And so they got help to rewrite their algorithm, not in a parallel way, but in an incremental way. Wow. So rather than processing the raw data, they would build a proper pipeline where you would clean the data one hour or 1 day of data at a time, and then get the features out and blah blah blah, and then only at the last step you need all of the data to do the retraining if you have a neural net, for example. Right. And this is something that I bring up in my courses as well as one of the examples, and say that this is something you need to look for. This is important. In that case, I'm showing, if you want to count the most popular songs by country or whatever, right? You can. That's a 2-step algorithm, right? You can do first all of the counting of the songs to one data set, and then you can do the comparisons in the second set, and only the comparison do you need to redo. So the first level to parallelize at is on the workflow level, right? They figure out what steps you can do separately. And that's not parallelized with like Spark or MapReduce. That's parallelized with workflow orchestration. At Spotify, we use Luigi, which I happen to be fond of for these things, but there are others like Airflow, Dagster, and so forth nowadays. And this workflow, that's one of the most common mistakes in big data, not grasping and getting full hold of these workflow engines. I see so many companies that struggle with this, even companies that you think are fairly mature. That's one of the things that we really nailed at Spotify and became good at.
So instead of reprocessing all the data,
let's talk about this
do
now,
it incrementally.
But we're talking about some really important stuff here that, it's Greek to me, and I think it's Greek to a lot of people starting up with big data, and they have a traditional hat on. They've been doing data warehousing. So what are you talking about when you say you're breaking down the workflow? And what is Luigi? What is Airflow? What is workflow orchestration?
Those are good questions. So Luigi, Airflow, and so forth, we call them workflow orchestrators. They are basically the data equivalent of a build system like Make or Maven or Ant or Gradle.
What's their purpose?
Their purpose is to figure out what data you want to have processed, which you specify by specifying your the sort of desired data sets that you want out and the dependencies between them. So in order to calculate the most popular songs for this month per country, I'm going to need the data for each day during this month, right? So that's 30 basic data sets. And in order to compute them, I need to and do this in 2 steps. So I take the events from all of the songs and I do that in one step, and per day count, do all of the counts per country. And then in the second step, I do it on a sort of monthly basis where I compare. So in the workflow orchestrators, we describe these dependency patterns. And anybody who has worked with software is familiar with this, in particular if you work with old tools like Make, where you say, I want this software artifact to be built. Nowadays, it's a container image, but it used to be a jar or an executable. And in order to do that, you need to build these object files from source. And in order to get this source file, you need to build this generator of source and so forth. So that's another type of dependency tree. And every time you run these sort of dependency management tools, they will figure out, well, I already run these tools, and so I don't need to do that again, and the information hasn't changed. So let me just do the last little piece, right? And any software engineer will expect these tools. And if you go back to when my dad used to work, that he would write scripts that did this from the beginning to the end, like 30 different invocations of the Fortran compiler. And because that was the sort of the state of art at the time, and it wouldn't care whether something actually needed to be rebuilt or not. It would just do everything from top to bottom. But now, fast forward to 2020, we still see many companies working in this manner with data. They have a script where they run everything from top to bottom and do that once an hour or once a day or something. And that give. You can make a factory that way, but it is very, very fragile, because if something breaks somewhere, your whole pipeline will break down.
I think this is talking about why big enterprises do not succeed with their big data efforts or getting value or getting really speed and all that. I think there's a fundamental misconception, and I think there's a lot of people who moved into this space that started in the data warehousing space. They started with the star schema ideas and all that. So could you elaborate a little bit about what is the fundamental difference in thinking here?
That gets us back to the factories again, right? It's thinking. If you go back a bit in time, or how many of the enterprises still work, they're still working with like craftsman's tools, and so they're working with the data equivalents of like hammers and screwdrivers, which is in data terms that's Excel or manually typing SQL, right? They have gone in some cases gone from that level to the power tools, the
data warehouse,
the data warehouses and Power BI, which is still a craftsman's tool.
But the tool.
But they're powered by machines.
I'm using the electrical screwdriver.
Exactly. But there's still more or less steered by humans. And the mature data warehouses, they start to touch on these pipelines where you see the ETL flows running each day and so forth. But they are in general, when you work with them, you are in general not able to go back and correct things if they go wrong, because you don't have the flows set up so that you can easily throw out a new flow. Or if you have a bug somewhere, you can't just delete and build everything from the beginning. They're still made to run on the daily basis and so forth. And that's why you have to do all of this modeling up front in the data warehouse with your star schemas and your satellites and your data vaults. And you have to think very carefully how you do to handle the slow changing dimensions and so forth. All of that thinking is unnecessary in a data lake environment, because you have the raw data, and if you do something wrong, you create a new pipeline and process it in a different way.
And just to wrap this up then, do we need both, or do you think carefully, like, why do we need warehouses? Forget about that. It's a different way of doing it. Just learn it. Or is these different use cases in the end where the data vault schema or the star schema has a place? Or you essentially say, rethink, relearn, and we can get to the same result in a different way? Where do you stand here?
The long term, and in data mature companies, the data warehouses have one purpose left, and that is for exploratory analytics. To have a sort of a prepared data workbench where you can turn things around. So you usually have hyperdimensional cubes that you sort of shift around.
So a lot of data. So you've created a super data set to explore.
Something like that, yeah.
But from an operational point of view, no.
No, not. You feed humans with the data warehouse, but you don't feed machinery anymore through the data warehouse. And reporting is, if you are used to a data lake, data platform, a data processing environment, or the sort of monostyle data factory environment, and used to data ops, doing all of the reporting and so forth, that usually in a bank lives in the data warehouse, that's easier to do in a data ops data factory setting. And in fact, that was
the reports.
That was one of the major.
So this is interesting. So you say data warehousing is not for reports. I like it.
I mean, if you look at companies that have had the data warehouse, yes, their reporting is going to be in that data warehouse for a very long time, for legacy purposes. And maybe it's never a good idea to shift. But when I joined Spotify, the technical username of that we used to access Hadoop was reporting, because that was the first purpose of the Hadoop cluster, in a sense. And reporting never left Hadoop, because it's so much better to do it there. And we
So this is really interesting, because we get the consultants, the management consultants, they're trying to build this storyline, and you are telling me, well, think about it. Reporting can be done beautifully this way.
Absolutely, and that was actually a power in terms of business value as well, because I was doing royalty and reporting for a while, and the manager said, we're the sewer of the company. Everything that's ugly downstream, it floats and it ends up here, because we were one of the few teams that cared a lot about data quality.
So royalty reporting is this.
Because if you deal with the finance stuff, you care about the quality, whereas for recommendations, well, doesn't matter all that much. Anyway, so we had to do lots of like repairs of broken data, and that turns out to be a lot easier if you have a powerful programming environment. And at some point there was a renegotiation with the contracts and so forth, and much of the royalty calculations and reporting is contracts with record labels translated to code, right? And after these renegotiations, they would come back and we would look at this and say, well, you actually, in order to ship the right royalties to these artists, you have to look 2 weeks ahead in time or something, but you're supposed to do that within 3 days. Like, what are you giving us? And most of the cases were simple, but some of the cases were really difficult to like implement in code. And they looked nice on legalese, but in code difficult because of the data dependencies. And we used to swear about these things, right? And can't they have a software engineer on that negotiation table? But it actually then we realized, well, wait a minute, this is actually a very powerful feature. Because we saw some blog post of I think it was Airbnb's reporting pipeline, and we realized we were 5 years ahead of them in terms of being able to express things with reporting, and being able to express complex like business relations was a feature that enabled us to get the contract signed, and that's what Spotify lives and dies with. Right?
It's a very interesting, like completely different angle on the traditional BI versus big data story. And very interesting.
Also, if you look at reporting, which is reporting what has happened, if you take the same code and you tweak it a bit, it turns out that you can also do like forecasting and financial prognosis. And if you have a powerful data factory, instead of giving the reports at the end of the month and a few days after the end of the month for various reasons, you can actually give the updated reports on a daily basis, so that how your how your financials are flowing and so forth. And this was very easy for us. We thought it would be difficult when we got the demand, but these things turned out to be really easy because the factory was in place. And this has much more business impact than any AI or machine learning, at least at the maturity level what we are today.
So you think this is going straight down to real hardcore operational waste on a daily basis in 90% of our Swedish businesses.
Exactly. And this, getting the data democratized so that people can use it, getting it structuring and building the factories so that you can do things, that gives, that's where the bulk of the value in data processing is. It enables AI and machine learning and so forth, but you have to get grip on these things before you actually
but to conclude, if you get really good at the data factor idea, this is I talk about to become data and AI ready. So getting the data part right, the data processing part right, it's immediate value now, and it sets you up for AI.
Yes, exactly. It's a prerequisite.
It's a prerequisite, but it's actually you can squeeze value now.
Yes.
Even with the AI train also moving in its pace.
Yes. And maybe you've seen there's this triangle with the what's going to help me here, Anders? The Monica Rogatis.
The Venn diagram, or what?
No, the fundamental needs of AI. What's called the basic needs of AI or something like that. It's a reference to a psychological model where you say that for you as humans to thrive, first we must have food to eat and shelter and the basic things.
For AI to thrive, it needs
exactly. And after you have food and after you have longevity and can protect your children and so forth, then you can realize yourself and paint art on the caves and so forth. Right?
Almost sounds like Maslow. So what's the Maslow of AI? Yeah.
Exactly.